Since we are in now part 9 video. In part 9 video, what we are going to see is a very important theorem. The theorem name is Pythagoras theorem. Okay, so for up to part 1 to part 8, how many theorems we have seen? We have seen 4 theorem, isn't it? The first theorem name is what? We can say it as basic proportionality theorem or Thales theorem. Then the second theorem is converse of Thales theorem. What is the third theorem? Angle bisector theorem. The fourth theorem is what? Converse of angle bisector theorem. So in up to part 8 video we have seen 4 theorem and we have completed up to exercise 4.2. I hope you all completed your classwork and as well as your homework, isn't it? Okay students, now in part 9 video, before entering into Pythagoras theorem, first we want to learn about some note. Okay, I am going to explain this note first. In a right angle triangle, the side opposite to 90 degree, which is what 90 degree means, the triangle is what? Right angle triangle. That only they have written, the right angle triangle is called the hypotenuse. So now consider students, I have drawn here right angle triangle. Right angle triangle means this one line will be straight, one side will be straight. So if here box, if they represent box like angle, if they represent, if they are not giving 90 degree also, you have to consider it is 90 degree. Okay, so opposite to this 90 degree, what side is that? They are saying that it is called the hypotenuse. Opposite to 90 degree is called 90 degree opposite, what side we are having? This side, which is called hypotenuse side. Clear all of you? The other two sides are called. Now we have said that this is the hypotenuse side. Then this remaining two side is called what? Leg of the right angle triangle. Okay. So this is the hypotenuse side. With this leg and this leg only, this is standing. No. So only they are saying that the other two sides are called legs of the right angle triangle. Okay. This is one leg and this is one leg. Clear all of you? In third note, what they are saying is the hypotenuse side will be the longest side of the triangle, they were saying. So when compared to the two sides, which side will be the longest in triangle? The hypotenuse side will be the longest. For example, if this side is 4, this side is 6 means, then obviously this side will be more than 4 and 6. Okay, so here 4, here 6 means here will come more than 4 and 6, which means it can be 8, it can be 7, any number, but it should be more than this 2 centimeter. Clear all of you? The hypotenuse side will be the longest side of the triangle, they are saying. Then the last point, last note is very important. This note sometime will be asked in your 1 marks. So listen, in India, Pythagoras theorem is also referred as Baudian theorem. Baudiana theorem. So in your exam also, sometime instead of state and prove Pythagoras theorem, they can ask you state and prove Baudiana theorem. So you should not just blink. So Baudiana theorem is otherwise called as what? Pythagoras theorem. Clear all of you? So this last year itself in quarterly and half yearly they have asked in 1 marks. Clear all of you? This is very important note. Okay, now next we are entering into our Pythagoras theorem. Students, in part 9 video we are going to see theorem number 5, which is Pythagoras theorem. So this theorem is very important theorem. And this is very easy when compared to other theorem. This theorem is the very easy theorem. Now I am going to explain about the statement. In a right angle triangle, the square on the hypotenuse is equal to the sum of the square on the two sides. Students, can you able to understand anything from the statement? What they are saying? In a right angle triangle, The square on the hypotenuse is equal to the sum of the square on the two sides they are given. So in a right angle triangle means what triangle is that? What is the angle of in right angle triangle? The angle is 90 degree. So I am marking here 90 degree. Okay, um, I am writing here 90 degree. Okay, so in a right angle triangle, suppose here 90 degree, we are having three sides, isn't it? So how many sides we are having? This is first side, this is second side, so this is third side. So among the three sides, which is the hypotenuse side? Hypotenuse side is what? Longest side. We have seen in note, isn't it? Yes. Hypotenuse side is what? Longest side. Where this hypotenuse side will come? Hypotenuse will come the opposite side of 90 degree. Where 90 degree is there? Opposite side. Which side we are having? That side we will say it as hypotenuse. So now this is our hypotenuse side. Clear all of you? Okay, that only they were saying. Suppose I am giving the name. Here I am taking A, here I am taking B, here I am taking C. Okay, clear. Now in the statement what they are saying? In a right angle triangle. I have drawn right angle triangle. Isn't it? 90 degree triangle I have drawn. Next, the square on the hypotenuse. Square on the hypotenuse means now opposite to 90 degree we are saying this side as hypotenuse. Square on the hypotenuse means this side, what is the side? BC. Square, they were saying square. Square on the hypotenuse. Hypotenuse side is BC. So I am writing BC square is equal to, they are given. So I am writing is equal to sum of the, what they were saying, sum of the squares on the other two sides. So which means what? This side is over now. Remaining two sides is what? One is AB, another one is AC. For that side also they are saying sum means what? They were asking to add two sides AB and AC. They were asking to add. How we have to add? Squares on the two sides, which means this side is what? AB. So for that also you have to put the square plus sum they have given. So I am doing plus. This side is what? AC square. Okay, this only we want to prove in this theorem. Clear students? B, what they were saying, in right angle triangle, the square on the hypotenuse is equal to, this is the hypotenuse side, so square means BC square I have written is equal to sum of the square on the two side. Two side is remaining is what? AB and AC. Sum means what? Add. So you have to square AB square plus AC square. So this we want to prove in this statement. Clear students, all of you? All of you are clear now? So in given we are going for proof now. So this is our diagram. The same diagram only I have drawn there. 90 degree. See here 90 degree in angle A, 90 degree we are having. Isn't it? Now we will go for the proof. Given in triangle ABC, this full triangle, in triangle ABC, angle A is what? 90 degree. Okay. Then to prove is what I told? AB square plus AC square. AB square plus AC square equal to BC square. Okay, that only we want to prove. Construction. What we are constructing in this triangle is, we are constructing the line AD. Okay, this line we itself are constructing. How this line we are constructing means, this AD line should be perpendicular to BC. According to that, we want to construct. Clear students, all of you? How we are constructing this AD line? Here to here one line is coming. So this D line, AD line should be perpendicular to BC. Perpendicular means what? This is the perpendicular, isn't it? So like this it is coming, no. So perpendicular means here 90 degree. If this side is 90 degree, then obviously this side is also 90 degree. So only I have represented there both side 90 degree and 90 degree. Can you able to see here? Here also 90 degree, here also 90 degree. Clear students, we itself constructing the line AD. It is perpendicular to what? This baseline BC. Clear all of you? Now we are going for the main proof. So for what we have seen? We have seen about given, to prove and construction. Now only we are entering into our main proof. Clear students? Now first in Pythagoras theorem what we have to do is we have to compare two to theorem using similarity criterion. Okay, first what are the two? So in this triangle totally how many triangles we are having? The full triangle, one triangle, then this offers another second triangle, then remaining this offers third triangle. So first what we have to do is we have to consider the full triangle. Students, see here. Now we are having a full triangle ABC. Isn't it? Here in A we are having 90 degree. Okay. Now first what we have to do is we have to consider this full triangle ABC. See, I have drawn separately. Then after in this part you have to leave it. Only you have to take ADB. ADB. First step you have to compare the whole triangle with one part. Then afterwards in second condition what you have to do is this whole part with this remaining part. Dear students, first we have to compare this full triangle with this only this part. Okay, then second part is we are going to compare this full triangle with this remaining ADC. This part alone we are going to compare. Clear students? So now see students, first part we are comparing triangle ABC and ABD. ABC means what? This full triangle ABC. And which triangle we are comparing? ABD. ABD means what? ABD. This part. Okay, full triangle, first this part we are going to compare. Now you see students, here the A angle is what? We have drawn 90 degree. Similarly, this D angle is what? 90 degree. Okay, then you compare these two triangles, which is the common angle we are having. We are having commonly here also B, here also B. So, which means what? We are having angle B is common to both the triangle. Isn't it? So, I have written angle B is common. Next, if you see here first triangle angle A is 90 degree. In this angle D is 90 degree. Isn't it? So only I have written BAC is equal to BDA. So middle angle if you see here also A, here D. So here A is what? 90 degree. D is what? 90 degree. That only angle A is equal to angle D is equal to 90 degree. Clear students? This is the full triangle. In this full triangle, I am comparing the full triangle. This is full triangle. With that what? One portion here 90 degree. Clear all of you? This is ABC full triangle. This is ADB. This triangle. Here angle A 90 degree. Here angle D 90 degree. So only I have written angle A, angle D equal to 90 degree. So now how we are saying this is 90 degree? Given angle BAC is 90 degree and by construction we have constructed now this line AD line, and by the construction and this D angle is what? 90 degree we are writing. Clear students? So now how can we say this triangle ABC is similar to triangle ABD? How we are saying these two triangles are similar? We are saying by this is also one angle. Okay, you can write in the bracket. This is also one angle. So now by AA criterion we are saying that, see below I have written by AA similarity criterion we are saying that triangle ABC is similar to triangle ABD. Triangle ABC means what? Full triangle ABC is similar to triangle ABD. Clear all of you? Both the triangles are what? Similar. I hope you all understand up to this. Isn't it? Now, where we have learned about the similarity criterion in part 1 video, we have learned about similarity criterion. Isn't it? If both the triangles are similar, then the corresponding sides are what? Proportional. Yes, very good. If both the triangles are similar, then the corresponding sides are proportional. Students, see here by similarity, by A similarity condition, now we have saying that the corresponding sides are proportional, isn't it? So now how we are going to write this is, now if you see here 90 degree, this box angle is 90 degree, here B is double angle, isn't it? So in this first triangle, box and 90 degree we are taking. First we are taking AB. So I have written AB. Similarly, in the next triangle, where that box and double angle is there, here box is there, double angle is there. So which side that is BD. So the for AB side, the corresponding side is what now? BD. So I have written below BD. Clear all of you? Students, in the numerator if I am taking AB, then similarly this side I have to take B, next side below denominator part I have to take AB. Only then if I do cross multiply AB into AB I will get AB square. Isn't it? Suppose if I am here taking AB, instead of AB if I am writing here something means, will I get AB square? No. So if I am in the numerator, if I am getting AB, similarly in the second part denominator I have to get AB. So that only AB into AB I can get AB square. What we have to prove? AB square we want to prove, AC square we want to prove, which is equal to BC square we want to prove. Isn't it? First we are going to show AB square now. Here by AS similarity criterion, we are saying that the corresponding sides are proportional. Okay, how we are going to write this proportional is, usually how we will write from here we will write, isn't it? Proportional means from here itself we will write, but now we are not going to write from here. So how we are going to write this? Now if you see students, here 90 degree and double angle is side is what AB. Similarly in the second triangle where 90 degree and double angle we are having BD. So for AB side the corresponding side is what? BD. I have written. Clear? Then equal to you have to put in the below you directly you write AB. Okay. Now in the below part in which triangle we are seeing BD? Here only no. So here below part we are writing AB. Now we have to see the second triangle. In the second triangle where we are having AB. Double angle and nothing, no angle I have marked. So double angle and nothing AB. So here also where double angle and nothing is there, BC. Double angle and nothing is there. So the corresponding side is what? BC. So that you have to write BC divided by AB. Clear? Students, first you have to compare. This is whole triangle. Whole triangle you have to write in the numerator. Okay, the one part of the triangle that you have to write in the denominator. Clear students? Clear? Now AB how we are writing? 90 degree double angle. Similarly here 90 degree double angle is what? BD. So AB divided by BD we have written. Equal to, if in numerator AB then denominator should also have AB. So that I am itself writing AB. Okay. This denominator part which triangle I have to see? This one, this part of the triangle I want to see. In this where BD is coming. Okay, sorry, in this where AB is coming, AB, double angle, no angle. So here you see, where double angle, no angle is coming, BC. So write that in numerator. Clear all of you? Up to this is clear. Now afterwards, we are doing cross multiplication. AB into AB is what? AB square is equal to BC into BD. Mark that as equation 1. Clear students? Now so far what we have seen, we have compared this full triangle with one part. Okay, one part means what? This part. Okay, we are not taking. Only we are comparing the full triangle ABC with this one part. Now we are going to see what? Now we are going to compare the full triangle with the remaining part. Remaining part is what? Remaining part is A. Remaining part is like this, it is coming. A, here D, here C. Remaining part is here D we are having 90 degree. Clear students? This is full triangle ABC. First off we have compared and we have marked as equation 1. Now in second part we are going to see this remaining part of the triangle with whole triangle. Clear? Now only we are writing second part. Compare full triangle ABC. Triangle ABC. And next part is what? ADC. Clear all of you? ADC we are seeing. See students, in this both the triangle which is the common angle we are having. Here also we are having commonly C. So here put double angle. Here also you put double angle. Why we are putting double angle? Because already we are having marked one single angle. Now next angle you mark it as double angle. Clear? So now I have marked here C double angle, here also C double angle. So now here C is common, here C is common. So in first line I have written C is common. Clear? Now here A angle A is 90 degree, this side angle D is 90 degree. Isn't it? So how can I write now? BAC. See here BAC equal to ADC. Which means what? In middle what angle we are having? AD. So angle A and angle D are what? Both are what? 90 degree. So I have written 90 degree. Clear? If you don't know, you can compare, you can see this triangle also. This is full triangle ABC. Here angle A is 90 degree, here angle D is 90 degree. So only I am writing BAC 90 degree is equal to ADC. This is equal to 90 degree. Clear? Up to this all of you are clear? Next, afterwards I am going to write the remaining part. Now listen. Now we have said that angle C here, angle C is what? Common, we have proved. Next, angle A is 90 degree and angle D is 90 degree, we have proved. How we are saying this now? Given BAC 90 degree and angle CDA is equal to 90 degree. So now we have proved this is one angle, this is one angle. So by what we have done here, the same thing here also we are doing. Clear all of you? So therefore triangle ABC is similar to triangle ADC. Clear all of you? So if the triangle is similar, by how we are saying it is similar? By AA similarity criterion, we are saying these two triangles are similar. If the two triangles are similar, the corresponding sides are what? Proportional. Clear students? We want to prove is what? We want to prove AB square plus AC square equal to BC square we want to prove. But we have got one AB square. Next what we have to got? AC square we want to get. For that what we are doing is first we are taking the BC. Okay, BC where we are having first you see here this in B side any angle you are having? No angle you are having, which means what? Nothing the angle we are having. Now if you see here BAC is equal to ADC equal to 90 degree we are having. So students, now if you see here angle in this side B, whether we are having any angle? No. Similarly in this triangle any A we are having any angle? No, we are not having any angle. First we are taking BC. BC means here no angle, double angle. Similarly you have to see in the second triangle where no angle, double angle is there. Here no angle. So here double angle. So the BC you have to write numerator. Now here the corresponding side is what? AC. How? Here no angle, double angle. Here no angle, double angle. So for BC side, now the corresponding side is what? AC equal to. I told you before itself, here if here AC, then here also you have to write AC. So that only if you multiply AC into AC, we will get AC square. Clear students? So now I have written here AC. In first numerator part, I want to see in the first triangle, isn't it? I have written in the numerator AC. Where that AC is coming, 90 degree double angle side AC is coming. Similarly, in the second triangle, you see where 90 degree and double angle is coming, DC side, isn't it? So AC divided by DC you have to write. Clear students? How we are writing corresponding sides in proportional? Listen one more time, I will explain you. Here no angle, double angle BC I have written. Similarly, see the next triangle where no angle, double angle AC. So for BC side, the corresponding side is what? AC. One side is over. Now we are coming to next side. We have written numerator AC. So in first triangle we have seen AC, which means 90 degree double angle is AC. Similarly in the second triangle where 90 degree and double angle is DC. So I have written DC. The next step what we are doing? We are just cross multiplying. So how we are doing cross multiplication? AC into AC. AC into AC is what? AC square. Next DC into DC. Okay. Now AC into AC is AC square equal to BC into DC. Mark that as equation 2. Clear students? mark that as equation 2. Now you see here equation 1 and 2. Now what we are going to do is we are going to add equation 1 and 2. See, adding 1 and 2. Which means in this first equation left hand side what we are having ab square. So I have written ab square. Adding means so I have written in middle plus. Here in this equation 2 what is in left hand side ac square equal to. Clear all of you? First we are adding the left hand side one side equal to, then we are adding the right hand side one side. Clear students all of you? Here I am writing ab square plus AC square equal to, here the right hand side is what? BC into BD. So I have written BC into BD plus here what is the right hand side? BC into BC. Clear students? Now you see here also BC I am having, here also BC I am having. So what I have to do? I have to take commonly BC out. Here one BC, here one BC is there, no? So I am taking that BC commonly out. So, if I take commonly BC, out, what will I do? What will BC is outside? Remaining here, what is there? BD. You write that BD inside. Middle plus. Here that BC came out. Remaining is what? DC. So, write that DC. Clear students? Now, what we have got? BC into BD plus DC. Now, what is that BD plus DC? See here BD we are having plus DC. We are having, isn't it? So BD plus DC I can write as what? This full length. Isn't it? B to C, that full length only, no. BC, this full length BC, how we will write? BD plus DC we will write, isn't it? So in that bracket we are having BD plus DC. So now I can write, instead of BD plus DC, I can write the full length BC. Clear all of you? So, and below I am writing BC, BD plus DC is what? BC. Now BC into BC is what? BC square. So in this side what we are having? AB square plus AC square equal to BC square. That only we want to prove here, isn't it? So hence prove. Students, all of you are clear? Nothing in this we are having. See, first you are going to take this full triangle and you are going to compare with the first part. This part you are going to compare. Next you are going to take this full triangle, then you are going to compare with the second part. Okay, the only concept here you are using is similarity criterion. Okay, A is similarity criterion you are using. Okay, if you see in the first part, angle A, angle D is what? 90 degree. In angle B is common. Okay, first we want to get AB square. So you write this AB here. So here if you are writing AB, immediately in this next part denominator you write AB. Okay, so here AB if you are taking here, AB what? 90 and double angle. This side you see what? 90 and double angle BD. So we are writing here BD. Clear all of you? We have written already AB here. Here AB is in denominator part, we will see the second triangle, isn't it? So AB means what? Double angle, no angle. Similarly in that triangle you see double angle, no angle is BC. Cross multiply, mark that as equation 1. Okay, next we are going to compare the full triangle with the second this of. Similarly here angle A is equal to angle D, angle C is equal to angle C. Because angle A and angle D are what? Angle A and angle D are 90 degree, angle C is common. So by AA criterion, again the two triangles are similar. If the two triangles are similar. Now we have got AB square. Next we want to get AC square. Isn't it? Write that AC below. So then if you do cross multiply, you will get equation 2. Okay. Next afterwards you have to add 1 and 2. We will get this. Clear all of you? You go through the video 1 or 2 times. It is very easy theorem. If you are solving and seeing means it will be very easy for you. Okay students, now based on this theorem in exercise 4.3 we are going to do the problems. Now we'll see the problems. Students, I hope you all understood this Pythagoras theorem, isn't it? Now you write and see this theorem how you have to write your classwork. Write the heading Pythagoras theorem. Below that you write the statement. Below that you draw the diagram. Then proof given to prove construction. After drawing this diagram you can draw in the side. Below this compare ABC and ABD. Below that you can write angle B is common. Okay, continuously you are going to write. Clear? Because of I am having small space, I have written congested, but you write freely, neatly in your classwork so that it will be easy for you to learn during the exam. Clear all of you? Okay students, thank you. In next part 10 video, we will see the exercise 4.3 which is fully based on this Pythagoras theorem. Thank you students.